Hi there, in this video we're going to look at the equation of a straight line. Now we're going to do it graphically using an online graphical calculator. So if you go into Google and you type in DESMOS, so that's Desmos, you'll get access to this graphical calculator and you can play about with it yourself. Now what we have here is in effect the graph paper here in front of us, and we have a point up here where we can write in the equation. So whatever equation we write in here, it will graph it for us on the graph paper. Now we're interested in equations of a straight line, so what we're going to do is start off with the simplest one I can think of. So let's imagine that you were to go along one and then up one, so that point there would be on the line, and then if you went along 2 and up 2, then that point there would be on the line. If you went up 3 and along 3, then that point would be on the line. So the points on the line are every single point where the y value equals the x value. Okay, so that means that the equation line we are interested in is all the points on the line where the y value, so we just write it out, the y value equals the x value. Okay, so there we have it, the equation of our line y equals x, and that's it drawn out for us. And you can see if you put a little pointer on it, you can see that every single x coordinate equals every single y coordinate, so that's 0.3, 0.3, and 0.68, 0.68. If you went up to 1, it would be 1, 1. Went to 2, it would be 2, 2. And if we went to minus 3, it would be minus 3, minus 3. Okay, I can get on to it there. Minus 3, minus 3. Okay, so that's the simplest line that we can think of. Now, what I'm interested in doing though is being able to derive the equation of every single possible line that we can draw. So what we'll do is we'll narrow it down initially. We'll say, let's imagine every single line that we're going to draw, initially they all pass through the origin. Okay, so we're going to look at all the lines, like say for example a line that say runs like this here through the origin, or runs up there like that through the origin, or runs this direction here down through the origin. Okay, so if we were to pick out another line to say if we went along 1 and then up 2, so that's a point in the line. If we went up along say 2 and up 4, we've got a point in the line, or 3 and we went up 6. So what we'd be doing there is every y coordinate would be twice the x coordinate. So when y coordinate is 1, sorry, when x coordinate is 1, the y is 2, x coordinate is 2, y coordinate is 2 times it, which is 4. Okay, so every y coordinate would equal, and we'll just write it down, every y coordinate equals 2 times every x coordinate. So there's our line y equals 2x, and you can see you put the pointer on that, and every single y coordinate is twice the x coordinate. Okay, so 0.49 times 2 is 0.98. Or if we went up to that point there, then it would be the y coordinate is 2, which is 2 times the x coordinate, which is 1. And if we went up to 4, the y coordinate is 4, which is 2 times the x coordinate, which is 2. Okay, so that's that y equals 2x. Now we could make it, and you notice it got steeper when we did that. We can make it even steeper if you were to make it y equals 3x. Now we can see it's getting steeper because if you imagine if you were here and this was the bottom of a mountain, you were climbing up a mountain and you got to the top of a mountain, and then that would be a very, very steep mountain. Okay, and we could make it even steeper if we went to say 5, so it's getting even steeper. But you can make it shallower as well. So if you went to just y equals 1x, okay, then it gets a little bit shallower. Okay, so you can see that this value here, it changes how steep or how shallow that line is. Now we can also make it, if we were to look at say 1 upon 2, so that's a half x. Okay, so in that instance there, that y is a half of the x value. Okay, so if you went along the line here and say you got up to that point 2, then the y value, which is 1, is half of the x value, which is 2. And you can see if you just put these numbers in, if you put in x equals 2, then it would be 2 times a half, which would be make y equal 1. Okay, so now what you can do, which is quite good in this tool, is you could put in y equals x. Now instead of putting a number in, so we were putting in 3 or 7 or minus 4 or minus 2.35, okay, so instead of putting in these values here, okay, what we can do is, let's imagine we have this thing called a variable, so a letter that just stands for every single possible value that you can put in. So we'll put that letter in, we'll call it m. Okay, so really what m is what m defines is the steepness of the line. Now in maths we don't call it steepness, we call it the gradient. Okay, so m is the gradient of the line. Now if you click on this little slider thing here, I'll give you the option to just slide this up and down. You can see how the gradient changes. So everyone's going to pass through the origin, but the gradient's going to change. So that's gradient 1, you go along 1 up 1, and there's the gradient 2, 3, 4, and it would go up to 5, 6, 7, 8, 9, 10, just get steeper and steeper. And then you can change it the other way around about when you get down here, and you got the gradient is negative 0.6, say negative 1, 2, 3, 4, it runs like that. Okay, so now one thing to note here, I'll actually zoom in the way, let's get to back to the value of 1. One thing to note is that whenever the gradient is positive, so that's positive 6, you notice that when you start off at a point, so you pick any point in the line, you can pick a point down here, and when you travel on in the positive x direction, so that's the positive x direction there, so when you travel the positive x direction, if the gradient is positive, then this value here, the y value that you choose to get back to the line, it's also going to be positive. Okay, so if you pick a point 0 and you went along this point to that point 1, okay, in this instance here, and you would be travelling up the way in order to get to the point on the line, which is point 6, okay, at the point where it's 6 here. Okay, so that means that every line that has got a positive gradient runs in this direction. Okay, and then the same thing whenever we look at a negative gradients, if you pick a point in the line and you travel in the positive x direction, then in order to hit the line you have to travel down in the negative y direction, okay, to hit the line. So that means that your line is in this direction. Okay, so every line that's got a negative gradient runs in this direction as well. Okay, so but we haven't, that little equation is quite powerful because it's tiny, it's only y equals mx, but that little equation y equals mx allows us to draw every single line that runs through that origin. Okay, so it carries a lot of information in it. Okay, now that's not every single line, because we could have a possibility of a line that say looks like this, you say y equals x, but what if we wanted to have the same line y equals x, but we wanted to have it passing through the point 1. Okay, in order to get it passing through the point 1 in the y axis, all you need to do is just add 1 onto it. So we add 1 on, then you have y equals x plus 1. Now you can see that there is parallel to the line y equals x, so it's running parallel, but it's just added 1 onto it. Now you could also have the line y equals x minus 3. Okay, so there's minus 3, it cuts through the x-axis, the y-axis at minus 3. Okay, so that means that this value here will tell us where the line is going to pass through the y-axis. So we could do the same sort of thing that we did with the gradient. We can look at that, we can say, well, we'll put in a variable and we'll call it c, okay, and that variable c represents all the lines, all the points in the y-axis. Okay, so if I pop the slider on, and again let's say we've got the line here, y equals x plus 1. Let's go back to y equals x plus 0. So c is 0, so all we have is y equals x, and that's just a line y equals x. So if we increase that to 1, you can see it going up to 1, 2, you see it running all the way up, or we can run it all the way down. Okay, if I zoom out you'll see it there. So it'll run all the way down. I'll get it so you can see actually all the way. So it'll run all the way down to -10, and it runs all the way up to 10. Okay, so now we've got a way of representing y equals x, but y equals x plus some value c, which will allow us to represent every line that runs parallel to y equals x. Okay, so what we can do then is we could write out a general equation. So now we've got y equals x plus c, but we can put our value of m in, which changes the gradient as well. So y equals mx plus c, and now we can do the sliding routine again. So let's put the value of the gradient, leave it at 1, and we'll put the value c at 0. So that's just a line y equals x. Okay, and if we change the gradient, it swivels it around the axis like that, so a positive gradient and then a negative gradient. So if we put that back to a value of 1, we can change the height as well, so the cutover point on the y-axis, so we can go up the way, it's plus 6 values, and we can go down the way, minus values. Okay, so it means that we can use these two values, the m, which is the gradient, and c, which is the point where it passes the y-axis, in order to define every single possible line. So let's say, for example, we'll just slide it at random. Okay, I'll slide it at random there like that. So that's going to be the line y equals 3x minus 2.6. So the gradient here is 3x. Okay, so what it means is you go up 3 and along 1, and the point where it passes the axis is minus 2.6, which is here. Come down there will be minus 2.6. Okay, so we can shuffle these about, and we can represent any line that we want. Okay, so let's say we'll pick that actual value there, we'll leave this one here, we'll put it to the gradient equals 1. Okay, and we'll let this slide. Okay, so we'll leave it to slide, and you can see it will slide up and down. Okay, you see it sliding up and down there. Okay, so now we can slide it up and down, and we can also turn it, rotate it round about as well by the gradient. Okay, so let's do both at once. If we were to, now when we press play on this, this will start drawing out every possible line. Okay, so if I press play that, press play that, then you can see that it represents us being able to draw every single line that we possibly can. Okay, so good idea maybe to get hold of this and have a wee play with it yourselves. Okay, but in essence what we've done here is we've used a graphical approach to derive the equation of a straight line, which is y equals mx plus c. Okay, now in the next video what we'll do is we'll go in and we'll just derive this same equation, but we'll just derive it using our pen and paper. Okay, thank you, goodbye.